Hello all. So welcome to today's discussion. So today we'll be having discussions on how to analyze and interpret z-test. So you should know that z-test is a parametric test. And like every parametric test, we are supposed to we are supposed to know the assumptions underlying the z-test. And within the question, you could see that beneath it, they've indicated show full working steps. That should signal to you that you are supposed to use some steps to solve your question. So the moment you are able to find out within the question, show full working steps, it tells you that use certain steps. And in this course, we have 6 main steps we are supposed to follow. And it is your duty to know the various steps and know what each step is expected of you to do. It is really essential. And within the question, certain clues has been given that should signal to you that you are supposed to use only one test, and that test is the only appropriate test that befits the question. Meaning that you can't use any other test with the exception of that test they want. So it means any other test that you use, you are what? You are outrightly or totally wrong. So this question, which is formulated, it is a typical z-test. And how do we know that it is z-test? It means we are supposed to find out the assumptions underlying z-test. And those assumptions has been indicated in the question. They are the clues that would inform you that, oh, use z-test or don't use the z-test, but use another test. So first, let's go through the assumptions underlying any z-test. With a z-test, always we compare a sample with a population. It means that within the question, they have what? They have drawn a sample from a population. Also, the thing that they are measuring, which is the dependent variable, it is always on either interval or ratio scale. Again, the population mean and the population standard deviation should be given in the question. So when you read and you realize that any of these 3 assumptions have not been provided in the question, it tells you that you shouldn't use z-test, but rather a different test. So let's try and find out whether these 3 assumptions, we can find them in the question. So the first assumption where we indicated a sample should be drawn from a population. You could see that from the question, the first statement in the question, they indicated the following data represent the height of a random sample of 10 basketball players, meaning that the 10 basketball players, that's a sample. Then these basketball players, they have been sampled from the university. So it means the university students, they are the population. We have a population consisting of a university student. Then out of this, we've taken only 10 people. That's 10 basketball players. So the 10 basketball players will be the sample. So this should signal to us that, oh, a sample, which is this, has been taken from what? From a population, meaning our first assumption has been satisfied in the question. When you realize that this assumption has been satisfied in the question, don't be in haste to conclude that you're supposed to use z-test, because other tests also have this same assumption. So go through again and find out whether the next assumption for z-test, you can find it, whereby we indicated that the dependent variable, so they are telling you, oh, we are measuring something in the question. So you ask yourself, what are they measuring? Within this question, they are measuring the height of what? Of the basketball players. So it means the height will be our dependent variable. Then you tune your mind back. When we're doing scales of measurement, we indicated that always height or any physical science construct is measured on ratio, whereas psychological constructs, they are measured on what? On interval. Height is a typical physical science construct, meaning that it is measured on ratio. And as I indicated with z-test, the dependent variable should either be interval or ratios. So long as height is on ratio, it means our assumption has been satisfied for z-test. Another assumption, meaning that the dependent variable, which is height, is measured on ratio scale. Then the third assumption for z-test has to do with the fact that the population mean and the population standard deviation should be given in the question. They indicated here, assuming the mean and standard deviation of height. And you know that when it comes to mean, standard deviation, variance, and standard error of the mean, we have its sample and its population. So in the question, you ask yourself, so the mean and standard deviation provided here, is it for the sample or for the population? They didn't outrightly indicate it, but they are telling you the mean and standard deviation of height of the university student. And right now we know the university student to be which one? The population. So this is the clue. So long as they've indicated university students beside the mean and standard deviation, that should signal to you that these details are what? Are for the population. So in situations whereby they had indicated the mean and standard deviation of height of the basketball players, then it should signal to us that they are talking about the sample. So it means the mean will be 168, then the standard deviation will be 10 centimeters because they indicated respectively. All right. So this is how you'd identify whether to use z-test or not. So let's go through the steps. Right now, we know we are supposed to use z-test. So we need to follow the steps. And with the steps, the first step has to do with we indicating choice of statistical test. And under choice of statistical test, you need to let your reader know the type of test you'll be using and why you decided to use that test. So you are indicating why. It's more or less like you spelling out or indicating all the assumptions underlining that particular test which befits the question. So right now, it means you're supposed to provide all the assumptions underlining z-test that to be found in the question. So first, you could see that with z-test, we're able to decipher that a single sample was drawn from a population. So that's what we've indicated here. Then we're also able to find out that the dependent variable was on what? On ratio. You could see that I just indicated is on at least interval. I did this intentionally. Sometimes you'll be torn between interval ratio. You know that it could be one of them. So if you are torn between selecting either interval or ratio, in order to be on the safer side, put it in this statement form, at least interval scale. When you put it like this, you are telling the reader that, oh, the thing that they are measuring, it could be either interval or ratio. Then it puts you on the safer side. Again, within the question, we were able to identify that the population mean and the population standard deviation were provided. So that is what we've indicated as part of the assumptions under step one. Then the last assumption, with the last assumption, you wouldn't find it in the question, but always add it where we indicate we assume the scores of distributions in the population are normal in form. You remember I said when it comes to any parametric test, with the last video that I did, the previous video, any parametric test, we transform its scores into a normal curve distribution. And how did we got to know that the test that we are using is a parametric test? The last video, I indicated that with any parametric test, the scale of measurement should be either interval or ratio. And we've been able to decipher that this scale of measurement is what? It's on ratio. So hence, whatever test that we'll be using is a parametric test. So z-test is a parametric test. And since it is a parametric test, we are supposed to also assume that the scores are on a normal curve distribution. So that is what we've indicated here. So basically, these are the things you state for any z-test question. Tell your reader that, oh, a sample is taken from a population. The dependent variable is on either interval or ratio. The population mean and the population standard deviation were provided in the question. Then you assume that the scores is on a normal curve distribution. So that's all when it comes to step 1. Then under step 2, you are supposed to state the hypothesis. And you know we have 2 types of hypothesis. We have the null hypothesis and the alternative hypothesis. Null hypothesis and the alternative hypothesis. Always with a null hypothesis, we represent it with HO. HO. Then with the alternative hypothesis, we represent it with H1. And always within the question, you're supposed to do, a hypothesis has been made. When we say a hypothesis, back in experimental psychology, you were told that a hypothesis has to do with what? A tentative statement or a scientific guess. So they've made a prediction in the question. You know, they are comparing basketball players and the entire university students. So they've made a prediction as to which one will be greater or which one will be taller or shorter. That's the prediction. And always the prediction you find in a question is for H1. It is always for the alternative hypothesis. So it means that within this question, they indicated how true would it be to say that basketball players are taller than the average university student? That's a typical prediction they've made. And this prediction will be for your H1, which is the alternative hypothesis. And you know a hypothesis is supposed to be in a statement form. So it means you're supposed to put it in a statement form rather than in a question. And we are making a prediction. So it means it should be in future tense. So it means you make it basketball players will be taller than the average university student. So after you've been able to decipher the prediction in a question, you ask yourself, this prediction, is it directional hypothesis? Is it a directional hypothesis or a non-directional hypothesis? Is it a directional hypothesis or non-directional hypothesis? And one thing is, a non-directional hypothesis is also known as two-tailed. And a directional hypothesis is also known as one-tailed. So how would you know that it is one-tailed or two-tailed in the question? For us to know that it is one-tailed, within the question, they are comparing a sample and a population. That's basketball players and university students. So they should tell you that either the sample is greater than or less than what? The population. So you could see that with this question, they indicated basketball players, which is the sample, is taller, telling you that the sample is taller than the entire university student, which is the population. So it means they've indicated the direction they expect one of the groups to be. One should be taller than, or one should be shorter than. The moment you see that they are using that, then that should signal to you that it's supposed to be directional. In some instances, they wouldn't tell you that, oh, one is taller than, or one is shorter than, or one is greater than, or less than. They will just say, oh, between the two groups, there will be an influence, or there will be a difference in their height. So when they say there will be a difference in their height, they haven't specifically told you whether this group will be taller than the other group or shorter than the other group. They just said, oh, between the two, definitely there will be a difference. So when it happens like that, you can't say your hypothesis is directional, but rather non-directional. Non-directional, because they haven't specifically told us which of the group is taller or shorter, or they haven't told us which one is less than or greater than. All right. So it means we know that our hypothesis is directional when it comes to this question. So that will be for H1. Then with HO, HO will be the opposite of H1. So since our hypothesis is directional, our HO, we are supposed to state two main hypotheses. So you can see under HO, I've made it HO1, HO2, meaning that we are stating two hypotheses for H1. So the next one, which is let me focus on the HO1, the second hypothesis I stated for HO. You could see that this one is the direct opposite of what? Of H1. We indicated basketball players will be taller for H1. With the HO2, which is the second hypothesis for HO, I indicated basketball players will be what? Will be shorter. So that's the opposite. Another hypothesis we can generate from this is that among the two groups, they will be equal. That's basketball players and university students. Their height will be the same. So putting it in the statement form, this is how you do it. The moment you say there will be no significant difference in their height, when you say there will be no difference, then you are telling your reader that they wouldn't be what? There will be no one will be greater than or less than. So it means they will be what? They will be the same in terms of height. So that's how you put it in a statement form. Apart from you doing this, you're also supposed to represent your symbols. You're supposed to represent your hypothesis using symbols. Okay. So in doing it, you could see that we were comparing a sample, which is basketball players, on a population. And in representing our hypothesis in symbols, we normally use mean. Mean. So since the basketball players, that's the sample, it means you are supposed to represent basketball players with a sample mean symbol. Then university student, which is the population, will represent it with a population mean symbol. So we are comparing this symbol with the other symbol. Then with the H1, we indicated the sample mean will be taller than the population mean. So since we are saying the sample will be taller, it means the sample mean will be greater than the population. So this is how you represent your symbols for your alternative hypothesis, which is H1. Then with HO, we indicated basketball players will be shorter this time around in terms of they'll be shorter than what? The population. It means that our sample mean this time around will be less than the population mean. Then the second hypothesis for HO, where we indicated there will be no difference between the two groups. So as I said, if we are saying there will be no difference, then we are telling our readers that the two groups, the sample and the population, they will be the same. So it means the sample mean will be equal to the population mean. So these are the symbols you represent when doing it. All right. So that's all for statement of hypothesis. So under statement of hypothesis, you are supposed to put or indicate your hypothesis in words and represent them using symbols. Represent them using symbols. Okay, so let's jump to decision rule. Decision rule, which is the third step. The third step has to do with decision rule. The third step has to do with the decision rule. Decision rule. Okay, so under decision rule, we are supposed to state a critical value. And there's a critical value. And for us to generate this value, a table needs to be given to us. So within the question, a table has been given. So it means within the question, a table has been given. And within the table, for us to read the table in the first place, we are supposed to know three key things. But with z-test, we need only two of the things. So for now, I'll highlight on only two of the things we need. So it means under z-test, for us to find this critical value, we need to know the level of significance. And you know the level of significance should either be 0.05 or 0.01 or 0.01. So you ask yourself, within this question, are we supposed to use 0.05 or 0.01? They didn't highlight on it. They were silent about the level of significance you are supposed to use. Hence, whenever they are silent or they don't tell you the level of significance to use in the question, always use the 0.05 level of significance. Then we move on. The hypothesis, was it directional or non-directional? You can see that they specifically indicated that it is what? It is directional, because they indicated one group will be taller than the other. So it is a directional hypothesis. So since it is directional, we are supposed to use certain things. So let me project the table that you are supposed to read your information from. So first, we know that our hypothesis, okay, is directional. We know that it is directional. So let me try and get to the table so that things will be simple for us. All right, so this is a typical Z-critical table that we are supposed to read our information from. Z-critical table. So in most situations, this will be provided during examination in case you'll be solving Z-test. So how do you know that this is the table for z-test, you could see on top they've indicated some selected critical values of z. Then it means you're supposed to use this table to generate your critical value. So first, you remember I said you need two things. First, your level of significance and whether your hypothesis is directional or non-directional. So you can see our level of significance is what? Is 0.05, and it was directional. Hence, we are supposed to select this value. But in situations whereby our hypothesis was directional and the level of significance was 0.01, then it means we should have selected this value. Also, had our hypothesis been non-directional and our level of significance being 0.05, then it means we should have selected this value as our critical value. That's why it is really relevant for you to know whether your hypothesis is directional or non-directional, and also the level of significance. When you get any of them wrong, then it means your critical value would also be wrong. So going back, it means that our hypothesis is directional and the level of significance is 0.05. So it means we are supposed to select this value, which is 1.64. Okay, so it means our critical value is 1.64. All right, so let me go back to the question and continue. So this is how you state it. You indicate at 0.05. So I'm telling my reader that my level of significance is 0.05 and the hypothesis was directional. Therefore, there's the z-test value, the z-critical value that I'm putting it. And why didn't I indicate negative, but rather positive? Because within the question, they indicated the sample basketball players will be taller than the population. So they'll be greater than the population. So out of this, I'm assuming that the value that I'll be getting will be positive. So it means I indicated positive 1.64. So since my critical value is positive, then it means that I'm supposed to indicate this rule. And this rule, it is a thumb rule for all the tests that we'll be doing. When you realize that your z-critical is positive, you compare the t observed. When you say the t observed has to do with the value that you'll be getting later, the main value that you'll be solving. We need to compare it with this critical value. But we are setting a rule that when the value that you'll be solving, that's the t observed, when it is less than the critical value that we generated, 1.64, we have no other option than to retain HO. But when it is greater than or equal to 1.64, we have to reject HO. So that will be for all when it comes to step 3, decision rule. Then the next step is step 4, computation. So you realize that from step 1 up to step 3, we didn't do any computation or any calculation. Step 4 is where you do all your calculations. And for one sample t-test, for a z-test, the formula for z-test is this. The formula for z-test is this. So the numerator is the sample mean. I couldn't get a symbol to represent the sample mean. So you know the symbol for the sample mean is x, then a bar will be on top. So it should be x, then a bar will be on top. But I couldn't get one. So it means that should be something like this. An x, then a bar on top. like this. So something like X bar, something like this. I couldn't get a symbol to represent it. Then with this represent the population standard error of the mean, which should be something like this. That one, so I couldn't get a symbol, so that's why I've indicated 0. So it should be something like this, then an X bar beneath. That's the symbol for population standard error of the mean. So it means we are supposed to solve these things. We need to find the sample mean, then the population mean, which is this, then the population standard error of the mean. That will be the formula for z-test. So within the question, we were given this population mean. We were given the population mean. And they gave the population mean to be 168 centimeters. So it means our population mean is 168. Then you were given this population standard error. You're given the population standard deviation. So the 0 that I've indicated, as I said, I couldn't get a symbol to represent it. So when you see the 0, it is something like this. That's for the population standard deviation. And that was 10. And you know the formula for population standard error of the mean is the population standard deviation, which is this, over square root of n. So that's what we've indicated here. So the population standard deviation over square root of n. And from the question, you were given the population standard deviation as what? As 10. And you know when you see n, it represents the sample size. So the total number of people, they were also what? 10. So per your calculation, your population standard error of the mean should be this. So right now, we've solved for the population standard of the error of the mean, which is the denominator. Okay, we have our sample mean, sorry, our population mean. The only thing we have to solve has to do with what? Our sample mean. And what's the formula for the sample mean? Is sigma x over n. Sigma x over n. Then you ask yourself, sigma x represents what? Within the table, the thing that they are measuring is our x. They were measuring height. So it means that height is x. And this says sigma x. It means add the total scores of what? Of x. So 180 plus 175 up to 167. And when you add them, you get 1752. So that will be your sigma x. And that's what we did. So it will be sigma x, which is 1752 over 10, getting a value of 175.2. So at the moment, we have all our values. We know our sample mean to be this. We know our population mean to be that. Then we know our standard error of the mean. So we can what? We can substitute the values into this formula. Okay. So that is what we did. We substituted. And when you substitute it into the formula, this is how it will be like. Then you calculate, and the final value will be this. So that will be our z observed, the z observed that we indicated at the step 3. So it means when you move it into 2 decimal places, you should get 2.28. So that will be our computed value, z observed. And that will be all for computation. And the next step has to do with decision rule. So under step 5, you are supposed to compare this z observed with our z critical. You know the z critical, we had it to be 1.64. And right now we know our z observed to be 2.28. So let me bring the decision rule that we made here and compare it and see what we are getting at the moment. So we had the z observed to be 2.28, and we indicated that when 2.28 or our z observed, when it is what? It is less than 1.64. It means that we have to retain, but when it is greater than or equal to 1.64, we have to reject. So you ask yourself, this z observed that we had, is it greater than or less than? You can see 2.28 is greater than 1.64. Hence, we have no other option than to reject HO. So it means this is how you state your decision rule. Sorry, this is decision rather. You state your decision. This is how you state your decision. So per the decision, Z observed, when you compare Z observed with Z critical, which is 2.28, you could see 2.28 is what? Is greater than 1.64. Therefore, you have to reject HO. So that'll be for all when it comes to decision. So on a decision, based on step 4, the value that you get, you compare that value with your decision rule, per the decision rule that you stated. Then you indicate whether you'll be rejecting or retaining HO. So after you've made your decision to reject HO, you move on to step 6. Step 6, the thing is, step 6 has to do with interpretation. And under interpretation, we are supposed to select one of the hypotheses, whether you are selecting the null hypothesis, which is HO, or H1. But for you to select any of them, it will be based on the decision that you've made. If you've made a decision to reject HO, then it means you have no other option than to select which one, H1, because the thumb rule is that under interpretation, select one of the hypotheses. We have 2 hypotheses. And here comes the case, you've made a decision to reject one of the hypotheses, which is H1. It means that under interpretation, you have no other option than to select the other hypothesis you didn't reject, which is H1. So under interpretation, you state H1 hypothesis. So for you to state it, you go back to step 2. What did you state? Step 2, which is statement of hypothesis. You indicated that basketball players will be taller than the average university student for H1. So that's what we need to state under interpretation. But this time around, we wouldn't put it in a future tense, but rather in a present tense, because right now we know the reality on the ground. So hence you make it basketball players are taller than the average university student. So that's how you go through the various steps using Z-test. So always remember that you are supposed to use the 6 steps to solve Z-test question and any other inferential statistical test we'll be doing. So it is your duty to know what each step is and what is expected of you to do in each step. All right, thank you so much, and I hope you enjoyed this recorded video. So that'll be the end of today's discussion.